Okay, in this section I just want to go over a couple different ways that we can describe or organize and summarize our data. The first one we want to take a look at are stem and leaf plots. Some of you may have seen these before, but I kind of want to go over an example here. Below are the number of home runs that Babe Ruth hit in each of his 15 years with the New York Yankees. We're going to make a stem plot of the data. Now here we have the number of home runs in each of these 15 years that he played with the New York Yankees. So this is our raw data. Now a stem and leaf plot means in this case we have two-digit numbers. So our first digit is going to be the stem, the second is going to be, our leaf. So we can see that we have home runs ranging anywhere. We've got 50s, 40s, 20s. That 20s is our lowest. So our lowest stem is going to be in the 20s. We also have some in the 30s, some in the 40s, some in the 50s, and I think, we have one in the 60s. So that is our stem there. So now I'm going to go through and kind of by a process of elimination, we're going to identify all of our leaves. So I can see that for the 20s, I've got 25 here and 22 there. So I'm going to X out both of those, and I'm going to write a 2 and a 5 here. When you're doing this, it kind of is helpful to line these up in columns. I'm going to have 30s now. He had a 35 and a 34. So I'm going to put the 4 and the 5, and I'm going to eliminate those so I'm not looking, so I can look past that a little more easily. And then we have quite a few years where he had home runs in the 40s. We've got a 41. Let me see, we've got two 41s. So I'm going to list those and X them off. We've got, here we have a 46, 46, 46. It looks like we have three 46s, so I'm going to write 3 6s and X those out. We've got a 47, and then we have a 49, I believe. 49. And then in the 50s, we've got a 54, a 54, and a 59. So we're going to go 4, 4, 9. And then 60, we've got one year we had 60. So we can kind of see that, we've got, home runs totaling in the 40s was most common. We can also see that it looks like it's somewhat of a, normal distribution here. It starts low, gets high, and so forth. So we can kind of look at it that way, and you can see I'm kind of putting the normal distribution on its side. But we need to answer this question. Is 60 an observation that falls outside the pattern of the observations and hence could be considered an outlier? We're going to have two different definitions for outlier, one when we're dealing with the mean, one when we're dealing with the median. But I just want to introduce the whole concept of an outlier. An outlier is, a data point far from the other data points. Now the thing here is 60 is, our highest, but it's just one more than 59, so it's not far from the other. So just generally speaking, we can say that, 60 is not an outlier in this case. Okay, so next we want to take a look at dot plots. Dot plots, each value is plotted and then stacked. This is really good for qualitative information. So we can see here our first example, we have some qualitative information. And the second one, we have some quantitative. So by qualitative, again, we mean that, no numbers, we have categories here. So this is looking at our different choices of snacks at a movie theater. Here we are looking at the number of children. So we can see that number of children in a family from 1 to 5. You can see that 3 is most common. Again, that has a little bit of a normal distribution, and we can look at that normal. We can apply that term normal distribution when we're talking about numerical data. You would not do that here with qualitative data, because there it just really depends on what order you put your data in, which categories come first, and so forth. So we can't really talk about the distribution on qualitative data. Now I do want to point out, and I want to make a note off to the side here, that both of these methods retain the actual data. And that's what makes both of these methods a good way to display your data, because you can kind of get an idea how it spreads out, but you're also retaining the actual data. Whereas down here on the rest of these, that's not the case. So in this first example here, a Pareto chart is a bar graph, but it's specifically for qualitative data. It's looking at these different categories. This is a very shrunk down example here, but you can see that we've got different categories. But the deal here is you're creating, it looks a little bit like a histogram, but it's for qualitative data, and you always put your largest category first, so it's in descending order. Okay, here we have a pie chart, and I think many of us are used to pie charts or circle graphs. They depict qualitative data. You could also use it to identify quantitative data as slices of a circle. The size of the slice is proportional, and that's really important when we're looking at circle graphs, is we can see very easily, just with a quick glance, if this is a large portion, if it's half, a third, or a quarter of the data. You can kind of get an idea of a data category in relation to the whole. That's what's really great about a circle graph or a pie chart. Bar graph, again, we've used a histogram, which is a special type of bar graph, but this uses bars of equal width to show frequency of categories of qualitative data. So you can see that the vertical scale represents frequencies or relative frequencies. The horizontal data or scale is going to identify the different categories of qualitative data. How many times can we write qualitative data here? Okay, then our last thing that we're going to look at this page, or in looking at our graphs here, a multiple bar graph. It has two or more sets of bars. Got an example of it here where we're comparing maybe, I don't know, male and female, some category or some different piece of information there. Okay, the other thing that we need to go ahead and take a look at are the plots that deceive. So the first thing that I want to point out is a no zero axis is going to exaggerate the slight differences. So what do we mean by no zero axis? When we look at these two bar graphs here, we can see that they're really depicting the same information, but this one is only a partial graph. The question is, do you agree with the court's decision to have feeding tube removed? We're looking at the responses from Democrats, Republicans, and Independents. But you can see here that this vertical axis starts at 53. So when we're looking at this, at first glance, it looks like, you know, these Democrats, you know, are heartless. I mean, they're almost 10 times the number of Democrats chose to, you know, remove the feeding tube in a court case or legislation or whatever, and just very few Republicans or Independents. But when you look more closely and really interpret the numbers here, that's not the case. When you look over here, this is a better graph because it has a zero axis. Whereas here this one did not. So when you're looking at this, you can see that the difference between the responses from Democrats, Republicans, and Independents are not all that different. So in other words, this first graph really exaggerates the difference. And therefore it's misleading. Okay, the last graph we want to take a look at is looking at pictographs. And generally, you do not want to use pictographs. It's really shying against that. Simply because pictographs, by doubling each side of basically in a pictograph, you're using some kind of a symbol to represent counts. And depending upon how you magnify the symbol, you really can mislead. So in this particular case, we're looking at these blocks. And these blocks are representing, giving a visual to the amount of money that someone can earn. Someone with a high school diploma, someone with a high school, or without a high school diploma, with a high school diploma, bachelor's degree, and then an advanced degree. We all know that you make more money the more educated you are. But I kind of doctored up my picture here, and I would like you to do the same. This is very misleading because in reality, you can make about 4 times the amount, your salary or your income, having no high school diploma versus having an advanced diploma. You go from $18,734 up here to $74,602. That's almost 4 times as much. But when you take each edge here of each block and, you know, make each edge 4 times as long as the edge of the original block, you are actually creating 64 little blocks. It's very misleading. Even though the side length quadruples, it has the visual display, or it gives the impression that salary is magnified 70, is times 64, and that is not the case. So basically, 2- and 3-dimensional figures or pictures are misleading. They're hard to interpret. Okay, so we'll leave that. That finishes chapter 2.